Final exam review. Question number 1. Convert 10 degrees to radians. So to convert degrees to radians, we multiply by pi over 180 degrees. Now we're going to cancel the 0 with 0, and we're going to end up with pi over 18. So pi over 18 is the answer. Convert 31 pi over 18 to degrees. So we're going to say 31 pi divided by 18 times 180 over pi. We know that pi cancels. And then we can reduce 18. So 18 divided by 18 is 1. 180 divided by 18 is 10. And then we have 31 times 10 is 310 degrees divided by 1 times 1, which is going to be equal to 1. So the answer here is going to be 310 degrees. The second question, you will need to build a unit circle. You will be provided with a blank unit circle on the exam. So you're going to write down sine 330 degrees is negative 1/2. Cosine pi over 6 is 1/2. Please pay attention to the sign. Sometimes you just write pi over 6 is square root of 3 over 2, sorry. So this is actually square root of 3 over 2. In my mind, translated as 60 degrees, but it's 30 degrees. And then secant 5 pi over 6. So we know that secant is 1 over cosine. So we're going to say this is the same as 1 over cosine 5 pi over 6, which is equal to 1 over cosine 5 pi over 6 is negative square root of 3 over 2. So negative square root of 3 over 2, you can say the reciprocal. So this is equal to negative 2 over square root of 3. We don't like the radicals in the denominator, so we're going to rationalize. We're going to multiply by square root of 3 over square root of 3. So we will have negative 2 square root of 3 over 3, and that is the answer. Secant 5 pi over 3, it is the reciprocal of sine 5 pi over 3, and we know that sine 5 pi over 3 is equal to negative square root of 3 over 2. So it is the reciprocal. It is going to be negative 2 over square root of 3. So it's very similar to the previous step, which is, I can immediately say that it's the same answer. So it's negative 2 square root of 3 over 3 for the same reason. We don't like radicals in the denominator. And then tangent 210, we know that tangent is sine over cosine, which means it's negative 1/2 divided by negative square root of 3 over 2. So negative 1/2 sine 210 divided by negative square root of 3 over 2, which is cosine 210. This is going to be negative 1/2 times the reciprocal, negative 2 over square root of 3. Doesn't matter where you put your negative. Negative times negative is positive. So it's going to be positive 1 over square root of 3, which is, we're going to rationalize because we don't like radicals in the denominator. So this is going to be square root of 3 over square root of 3. So this is square root of 3 over 3. And that will be the final answer. Sine negative 225. We know this is the same as negative sine 225 degrees because sine is odd. So this is negative times sine 225 is negative square root of 2 over 2, negative square root of 2 over 2, which is going to be negative times negative is positive. So I'm going to write the answer positive square root of 2, square 2 over 2. And the last one here, we have tangent and cotangent. Those are cofunctions. We know that cofunctions are equal if the sum of the angles is equal to 90 degrees or pi over 2, which means they are complements. So that is the step that I'm going to do to check. 3 pi over 7 plus pi over 14, is that equal to pi over 2? Let's check. So 3 pi over 7, I'm going to multiply that by 2, both numerator and denominator, in order to achieve the same denominator. The denominator here is 14 actually. So now I have 6 pi over 14 plus pi over 14, which is equal to 7 pi over 14. If you reduce this, you get pi over 2. So that is equal to pi over 2. As a result, tangent 3 pi over 7 is equal to cotangent pi over 14 because the angles are complements, so the cofunctions are equal, which means their difference is going to be equal to 0. If that is not the case, if you ended up with different angles that don't add up to pi over 2 or 90 degrees, then you're going to say, I don't have an exact answer because neither 3 pi over 7 nor pi over 14 is going to be on the unit circle. And I don't think you can use a combination of two angles in order to come up with a combination of two angles on the unit circle in order to come up with the angle in between the parentheses. So that is question number 2. Question number 3, you're going to need to create a triangle. For all of these, you will need to have the exact answer. So I'm going to try to sketch the triangle here in the third quadrant because it says it is in the third quadrant. I'm going to make it a triangle like this, and I'm going to name this theta because I have this theta here. And it says sine theta is equal to negative 2 over 5, so I know that is the opposite. I'm gonna label these. So this is opposite to theta, this is adjacent to theta, and this is the hypotenuse to theta. I know that sine theta is opposite over hypotenuse, so this is equal to negative 2, and the hypotenuse is equal to 5. The hypotenuse is always positive. Now we need to find the adjacent, so we're going to say a square is equal to 5 square minus negative 2 square. Minus negative 2 squared. So this is 25 minus 4, which is equal to 21. So a is equal to negative square root of 21 because this side is the negative side of x. So this is equal to negative square root of 21. Now, cosine theta is adjacent over hypotenuse, so it's negative square root of 21 divided by 5. Tangent is opposite over adjacent, so this is negative 2 over negative square root of 21. First, we're going to cancel the negatives, and then we're going to multiply by square root of 21 and divide by square root of 21. We will get 2 square root of 21 over 21. We like to rationalize because we don't like radicals in the denominator. Secant is the reciprocal of cosine, and we figured out cosine previously. So this is equal to 5 over negative square root of 21, which is the reciprocal of cosine. We like to rationalize, so we're going to multiply by square root of 21, divide by square root of 21. You will get 5 or negative 5 square root of 21 over 21. It really doesn't matter where you put the negative because it just means that the fraction is negative. Cosecant is the reciprocal of sine. So I have sine here. I'm going to find the reciprocal, which is negative 5 over 2 or 5 over negative 2. Cotangent is the reciprocal of tangent, so I'm going to focus on this because I know if I find the reciprocal of that answer, I don't need to rationalize. So the reciprocal of tangent is square root of 21 over 2, and the negatives are cancelled, so it's positive. Cosine 2 theta, I'm going to use the formula here. I know that cosine 2 theta, I'm going to write it here. So cosine 2 theta is equal to 1 minus 2 sine square theta. And the reason why I use this specific formula is because I have sine theta already here, so it's easier to deal with. So this is going to be 1 minus 2 times negative 2 over 5 all squared. We know if we square a fraction, we're going to square the numerator and the denominator, so this is 4 over 25. When we multiply fractions, we multiply the numerator by the numerator and the denominator by the denominator. The denominator of any constant is equal to 1. So we have 1 minus 8 over 25. We're going to write 1 as 25 over 25 because we need to have common denominators, minus 25, 8 over 25, and we're going to get our answer, which is 17 over 25. So the answer here is 17 over 25. Sine theta over 2, we know this is in the third quadrant, so sine is negative in the third quadrant. So we're going to use the other formula. So I'm going to erase this. I'm going to erase most of this work so I can fit the work for the last part here. Erase it one more time here. I have sine theta over 2 is equal to positive or negative, but I'm going to choose the negative because we are working in the third quadrant and sine is negative in the third quadrant. Square root of 1 minus, let me just erase that part of the line. 1 minus cosine theta over 2. We computed cosine theta previously in the first step, so we're going to use that. So it's negative square root of 1 minus negative square root of 21 over 5 divided by 2, which is equal to negative square root of 1 plus square root of 21 over 5 divided by 2. We need to remove the denominator here. We need to remove this denominator. So we're going to multiply both numerator and denominator by 5, and I don't forget to distribute the 5. So I will have negative square root of 5 times 1 is 5 minus, this 5 is going to cancel with the 5 of the denominator of square root of 21, so square root of 21 divided by 10. And that will be the final answer. I just can leave it like that. Negative square root of 5 minus square root of 21 over 10. So that would be the answer for question number 3. Question number 4, you will need to find the exact answer for cosine 255. 255 is not on the unit circle, so we're going to try to break it down into two angles that are already on the unit circle. We know that 225 is the sum of 210 plus 45. So we can rewrite this as cosine 210 degrees plus 45 degrees. When I see 5 here, I immediately jump to 45 plus something else. I'm going to use the sum formula for cosine to solve this, which is going to be equal to cosine the first angle times cosine the second angle minus, because this is plus, this is going to be minus, sine the first angle times sine the second angle. Cosine 210, the angle cosine 210 is negative square root of 3 over 2. So this is negative square root of 3 over 2 times cosine 45 is square root of 2 over 2 minus sine 210 is negative 1/2 times sine 45 is square root of 2 over 2. So now I'm going to do the multiplication. Negative square root of 3 times square root of 2 is negative square root of 6 over 2 times 2 is 4. Minus times negative is positive. 1 times square root of 2 is square root of 2 over 2 times 2 is 4. So I can combine them over one denominator 4. And I could say negative square root of 6 plus square root of 2 over 4. And that would be the final answer. Leave your answers as exact because you will not be allowed to use a calculator in this case. Question number 5, I would like to find an equation. So I need to find A, B, C, D. The first step is to find D. D is basically the midline. I'm going to highlight the midline here. As you can see, the midline is at 3, so D is equal to 3 immediately. The amplitude is the distance here, and in my case it is 2 units, so I'm going to say the amplitude is 2. And I know it's positive because sine is going up first and then it goes down. Let me highlight that. So as you notice here, sine is, this is a function of sine. It goes up first and then it goes down, so it's a positive sign, so I know that the amplitude is positive in this case. So A is positive. And then I will need to find C. C is equal to 0. because we don't have a horizontal shift, and then we will need to find b. We know that b is equal to 2 pi because that is the length period of sine function divided by the period. We know we can find the period if we find the distance between two valleys or two mountains, or I could say the distance between 0, skip 0 to the other 0. That is another period as well. So if you do that, you'll find that the period length is equal to 14. So I'm going to say b is equal to 2 pi over 14, which is going to reduce to pi over 7. Now I'm ready to write my equation. The equation says a sine b pi over 7x minus c. The minus c is 0, so I will leave it out, plus d, which is equal to 3 in this case, and that is going to be the equation. Question number 6. Question number 6. I'm going to solve this equation over one period. So I have 2 sine theta equals square root of 2. The key here is to solve for sine theta. So I'm going to divide both sides by 2. I will have sine theta equals square root of 2 over 2. I know that sine theta is positive in two quadrants, the first quadrant and the second quadrant. I'm looking for an angle such that sine that angle is equal to square root of 2 over 2. By looking at the unit circle, I realize that is pi over 4 in the first quadrant and 3 pi over 4 in the second quadrant. So I have two answers here, and I will leave them like that. So pi over 4 and 3 pi over 4 are my answers. Question number 7.